Hari Om. Hello everyone, I am Shrees. Welcome back to my channel. Today's video is of class 12 mathematics chapter 5 continuity and differentiability part 5. So make sure that you have watched part 1 to part 4. So today we are going through differentiability. Okay, we have completed continuity. Now we are going through differentiability. In class 11 we have already learnt about differentiability, right, and the process of finding derivative of a function. Right? The process of finding derivative of a function is called differentiation. Okay? The derivative. See, derivative is the differentiation. So, derivative is nothing but it is the rate of change. Okay? Rate of change. That is a rate at which the function is changing at a particular point. Okay? A function is differentiable at a point. See, a function is considered differentiable at a point if its derivative exists at that point. Okay, if derivative exists at that point, then we say the function is differentiable at that point. Or we can say a function is considered differentiable if left hand derivative and right hand derivative are equal. Okay, if like a continuous function, left hand limit and right hand limit and the value of the functions are equal, then we say given function is a continuous function, right? But here in differentiable function, left hand derivative and right hand derivative are equal, then the given function is differentiable. Okay, so and here also there are it has various applications in many fields. So some applications we will study in next chapter. And here when we recall our previous classes, we had defined the derivative of a function, right? That is, suppose f is a real function, f is a real valued function, and c be any point, okay, any point in its domain, okay, c be any point in its domain, then derivative of f defined by derivative of f at c, okay, derivative of f at c defined by f dash of c is equal to f of c plus h minus f of h divided by h, f of c, okay, f of c plus h minus f of c divided by h. It is the definition of a derivative of a function at c. Okay, this one we have already learnt in our 11th class. Okay, so here see derivative of a function is denoted as f dash of c. Derivative of function at c is denoted by f dash of c, and derivative of function, if y is equal to f of x, okay, if y is equal to f of x, if the function is of the form y is equal to f of x, then it is denoted by means derivative of y, okay, that is y dash or dy by dx, okay, or f of x, the derivative of, that is d by dx of f of x, that is derivative of f of x with respect to x. Now let's recall some derivatives of some standard functions, okay, that is derivative of x, d by dx of x with respect to x is 1, and d by dx of root x is 1 by 2 root x. d by dx of x raised to n is x raised to n minus 1, right? And d by dx of e raised to x is e raised to x itself. Okay, so d by dx of sin x cos x, d by dx of cos x minus sin x, d by dx of tan x sec square x, right? d by dx of cot x minus cosec square x, right? Okay. Then what about d by dx of sec x? Sec x tan x, right? Sec x tan x. And d by dx of cosec x is minus cosec x, cot x. Then d by dx of log x is 1 by x. So these all things we have already learnt in our 11th class. It is the derivative of some certain standard functions. Okay. Theorem, very important theorem. If f has a derivative at x is equal to c, then f is continuous at x is equal to c. I have already mentioned in introduction, that is every continuous function is a every differentiable function is a continuous function. Okay, that means see, if f has a derivative at x is equal to c, means its derivative exists and the f is a differentiable function at x is equal to c. Then we have to prove f is continuous at x is equal to c. Okay, so here differentiable, if a function is differentiable at x is equal to c or derivative at x is equal to c, then according to the definition of the derivative of the function, f dash of c is equal to limit h tends to 0 f of c plus h minus f of c divided by h. Right? It is the definition of the derivative of the function at x is equal to c. Right? That is f dash of c is equal to limit h tends to 0 f of c plus h minus f of c divided by h. So what we have to prove? We have to prove f is continuous at x is equal to c. To prove f is continuous at x is equal to c, we have to prove limit x tends to c, limit x tends to c, f of x is equal to f of c. It is the definition of the continuous function, right? So we have to prove this one. So here for that, let's write f of c plus h is equal to f of c plus f of c plus h minus f of c. Okay. See, we can write this one, right? Because f of c, when we cancel f of c, we will get f of c plus h only. So f of c plus h can be written as f of c plus h minus f of c. Okay, added and subtracted f of c. Okay, so here next f of c plus, here let's consider only these two terms, f of c plus h minus f of c divided by h into h. Okay, here we have multiplied and divided by h only for these terms. Okay, then so what is this? Okay, before that we have to take limit on both sides. Okay, apply limit on both sides. So it will be limit h tends to 0 f of c plus h is equal to, here also limit h tends to 0 f of c plus limit h tends to 0 f of c plus h minus f of c divided by h into h. Okay, we have applied limit on both sides. Okay, next see, what is this one? It is nothing but f dash of c, right? That is equal to limit, see what is limit h tends to 0 f of c. F of c is a constant, right? C is any point. C is any point. So f of c is constant. Therefore limit of any constant is nothing but constant itself, right? So f of c itself. So limit h tends to 0 f of c is f of c itself. Plus it is nothing but f dash of c. F dash of c. And limit h tends to 0 h. Limit h tends to 0 h. That is nothing but 0. Apply, substitute h is equal to 0, right? So that is nothing but 0, right? Limit h tends to 0, h is equal to 0. So it is into 0. So that is equal to, here this term will become 0. So it is f of c. So we have got limit h tends to 0 f of c plus h is equal to f of c. We have to prove this one, right? So here we have to, we can take c plus h is equal to x. Okay, put x is equal to c plus h. Okay, c plus h is equal to x. So when h tends to 0, see when h tends to 0, substitute h is equal to 0, what you will get? X is equal to c. That means when h tends to 0, x tends to c. Okay, that means when h tends to 0 means when h is approaching to 0, x is approaching to c. Okay, so here we can write limit x tends to c, here f of x, that is equal to f of c. Okay, so we have got limit x tends to c, f of x is equal to f of c if this function is derivative at x is equal to c. That means the function f of f is continuous at x is equal to c. Okay, f is continuous at x is equal to c. So remember, note it down, every differentiable function is a continuous function. Okay, as I said earlier, a function is derivative at x is equal to c if right hand derivative and left hand derivative and right hand derivatives are equal, right? So that is if f is derivative at x is equal to c if left hand derivative, how to define left hand derivative, L f dash of c, okay, that is equal to limit h tends to 0 f of c minus h minus f of c divided by minus h. Okay, see here minus h, that is here h is very close to 0 but less than 0, that is left of 0, that is called it is left hand derivative. Okay, so limit h tends to 0 f of c minus h minus f of c divided by minus h. H is a very small point and it is less than 0. Okay, it is a negative value. So that is equal to limit h tends to 0 f of c plus h minus f of c divided by h. It is the right hand derivative. Okay, so if these are equal, then the function is derivative at x is equal to c. Okay, so here left hand derivative is limit h tends to 0 f of c minus h. Okay, f of c minus h minus f of c divided by minus h. That is equal to limit h tends to 0 f of c plus h minus f of c divided by h. It is the right hand derivative. Okay, if these are equal, then given function is derivative, okay, or differentiable. See, look at this example, very important question, and it is 2008 and 2015 question. Okay, so very important. See, we have already proved in continuity that modulus x is continuous function. Modulus x is continuous at all the points. Okay, but here see, let function f from R to R defined by f of x is equal to modulus x. Okay, is f differentiable at x is equal to 0? Okay, here we have to check whether this function, modulus function, is differentiable at x is equal to 0 or not. So let's see. Here for differentiability, okay, so f is differentiable if left hand derivative and right hand derivative should be equal, right? Are equal. So here, so let's find the left hand derivative and right hand derivative. That is left hand derivative f dash of 0. See here at x is equal to 0. So c is equal to 0. Okay. So what is the equation? F dash of 0 left hand derivative at x is equal to 0 is limit h tends to 0 f of c plus h. So here c is 0, 0 plus h minus f of 0, right, divided by h. Sorry, it is minus, right? Yes, it is minus left hand derivative f of c minus h minus f of c divided by minus h. Okay, now that is equal to, here what is our function? Our function is nothing but f of x is equal to modulus x, right? F of x is equal to modulus x. That is the real function, f of x is equal to modulus x. So what is f of 0 minus h? That is nothing but modulus of 0 minus h. Right? F of x is equal to modulus x. Then f of 0 minus h is nothing but replace x by 0 minus h. Right? So that is modulus 0 minus h. Minus f of 0. That is f of 0. F of x is equal to modulus x. F of 0 is nothing but 0. Right? Divided by minus h. Okay. Now 0 minus h is nothing but minus h, and modulus of minus h is h itself. Right? Modulus of minus h, modulus of minus 5, 5 itself. Right? So modulus of minus 6, 6. Right? So here modulus of minus h is h divided by minus h, that is equal to minus 1. Okay. Now let's go through right hand derivative. Okay. Let's find right hand derivative at x is equal to 0. Okay, because here we have to prove, we have to check that this function is differentiable at x is equal to 0 or not. Okay, so here limit h tends to 0, f of 0 plus h, okay, minus f of 0 divided by h, that is equal to, here f of x is equal to modulus x, so f of 0 plus h is nothing but modulus 0 plus h minus f of 0 is 0 divided by h, that is 0 plus h is h, so modulus of h divided by h, that is equal to 1. See, here we have got left hand derivative not equal to right hand derivative at x is equal to 0, right? Hence we can say this function f of x is not differentiable at x is equal to 0, since left hand derivative not equal to right hand derivative. Okay, since left hand derivative not equal to right hand derivative, this function modulus x is not differentiable at x is equal to 0. Very, very important question. Another important question, similar question. Okay, the function f of x is equal to modulus x is differentiable on interval minus infinity to 0 and 0 to infinity, but it has no derivative at x is equal to 0. Prove it. So here, see, this one we have already proved, right? That is, the function has no derivative, that is modulus function has no derivative at x is equal to 0. That means the function is not differentiable at x is equal to 0. This one we have already proved. So here we have to prove this function is differentiable on all other points except 0. Okay, so that means it is differentiable on minus infinity to 0 and 0 to infinity. Okay, so our function is f of x is equal to modulus x, right? See, modulus x can be defined as minus x if x less than 0, right? When x less than 0, modulus x is equal to minus x. Modulus x is equal to x if x greater than 0, right? So here x less than 0 means the values of x belongs to minus infinity to 0. That means all the values are negatives, right? So here when x belongs to minus infinity to 0, here all x values are negative, right? That is less than 0. So in this case, f of x is equal to minus x. Okay, now here let's check the function, derivative of function exist or not. See, here not at a particular point, so here we will take f dash of x. Okay, f dash of x is equal to limit h tends to 0, f of x plus h minus f of x divided by h. Okay, that is equal to limit h tends to 0, f of x plus h is nothing but modulus x plus h minus, here f of x is equal to minus x, right? It is minus x. Here f of x plus h is minus x plus h. Okay, minus x plus h minus x. divided by h, that is equal to minus x minus h plus x divided by h. Here minus x plus x cancelled. I forgot to write the limit. Okay, limit h tends to 0. Okay, so here minus limit h tends to 0 minus h divided by h, that is equal to minus 1. It exists, right? See, this limit of derivative of this function exists. So now let's check in the interval 0 to infinity. Okay, that is x belongs to 0 to infinity. When x belongs to 0 to infinity, all the values of x are positive. That means greater than 0, right? When x is greater than 0, the modulus x is equal to x. That is, in this case, f of x is equal to x. Okay, now here, let's check the derivative of this function. F dash of x is equal to limit h tends to 0, f of x plus h minus f of x divided by h, that is equal to f of x plus h is nothing but x plus h, right? Here f of x plus h is equal to minus x plus h. Why? Because f of x is equal to minus x. Okay, so here x plus h minus f of x is equal to x divided by h. Here also x minus x cancelled. Limit h tends to 0. Okay, limit h tends to 0, h by h, that is limit h tends to 0, 1, that is equal to 1. See, here also the derivative of this function exists. Okay, so here we can say this function f of x is equal to modulus x is differentiable on interval minus infinity to 0 and 0 to infinity. And this one we have already proved, right? Because here it is left derivative of the function not equal to right derivative of the function at x is equal to 0. Therefore, this function is not differentiable at x is equal to 0. So here we say, here limit f dash of x exists on minus infinity to 0 and 0 to infinity. Hence, f of x is equal to modulus x is differentiable on minus infinity to 0 and 0 to infinity. Next is derivative of composite functions. Okay, how to find the derivative of composite functions. See here, this one we have already studied, right? F of x is equal to ax plus b. So what is the derivative of this function? That is d by dx of f of x, or we can write f dash of x is equal to, that is derivative of this first function, that means first term a, right? A into derivative of x, that is 1, plus derivative of constant is 0. So that is equal to a. Okay, then what about this function? That is composite function, means function of function. Okay, so f of x is equal to ax plus b whole cube. Okay, here it is the function of function ax plus b whole cube. One is x cube and another one is ax plus b. Okay, so here there is easy method to find the, say after going through 2-3 examples, say you will understand it more easily and you will be able to solve it very easily. Okay, so here see, listen carefully, f of x is equal to ax plus b whole cube. So how to find the derivative of such functions? See here, first of all let's consider the power. Okay, that is, we know that d by dx of f of x. Okay, and we have derivative of x raised to n is equal to n x raised to n minus 1, right? Derivative of x raised to n, that is equal to n into x raised to n minus 1. So in such functions, first we will consider the power. Okay, take it as a function, one term. Okay, take it as one term or take it as x. Okay, so x cube. So what is the derivative of x cube? that is nothing but x cube, derivative is 3x square, right? So here we will write 3 in place of x is nothing but ax plus b, okay? We have considered ax plus b as x, okay? So here ax plus b whole square, okay, into, next we will find the derivative of this function, okay, that is ax plus b. Derivative of ax plus b is nothing but a, okay? So here derivative of f of x, here derivative of ax plus b whole cube is nothing but 3 into ax plus b whole square, then derivative of this one, that is into a. So here 3a ax plus b whole square, okay, it is the derivative of this function. Okay, another example, let's take another example, composite functions. F of x is equal to sine of x cube, okay, sine of x cube. So here also it is the function of function, okay, sine of x cube, right? So one function is this one, another function is sine function, okay. So first of all here we will find the, what is the derivative of f of x. Derivative of f of x with respect to x is, see, first we will consider this one, sine function, okay, because sine of x cube, okay. So sine of x is, derivative of sine x is nothing but cos x, right? So consider this as x, okay, then it will be cos x, that is cos x cube, into, next we will find the derivative of x cube, okay, that is derivative of x cube is nothing but 3, derivative of x raised to n is nothing but n x raised to n minus 1, right? So here 3 x raised to 3 minus 1, that is 3x square, right? So here 3x square cos x cube is the derivative of sine of x cube, okay. See, this rule is called chain rule, okay, chain rule, derivative of chain rule, okay. So another example, let's take f of x is equal to sin x whole cube, okay, sin x whole cube. See, what is the derivative of this function? See, for this here, first we will consider the power, okay. First function is power, then sine, right? So consider this as x, then it will be x cube, right? X cube. We know that derivative of x cube is nothing but 3x square, right? So here we will write d by dx of f of x is equal to 3, that is sine x whole square, means x cube derivative is nothing but n x raised to n minus 1, 3x raised to 3 minus 1, that is 3x square. So here we have considered sin x as the x, right? So 3 sin x whole square, into, next we will find the derivative of sin x, that is cos x, okay. So it is the derivative of sin x whole cube, okay. This method is called chain rule. Next, another example, f of x is equal to log root x, okay, log of root x. See, here also it is the function of function. First one is log, then root x. So first we will find the derivative of log. Consider this as x, so it will be log x derivative is, log x derivative is 1 by x, right? So 1 by root x, 1 by root x, into, next we will find the derivative of root x, that is 1 by 2 root x, okay. So it is 1 by 2x is the derivative of log root x. Okay, now let's go through exercise 5.2 questions, okay. Differentiate the function with respect to x, okay. Differentiate the function with respect to x. First one is sine of x square plus 5. So here we will apply chain rule. Okay. So here also it is the function of function, right? Composite function. So sine of x square plus 5. So first we will differentiate sine with respect to x. Then into x square plus 5 differentiate. Okay. So here let's take f of x is equal to sine x square plus 5. Then f dash of x is equal to cos sine derivative cos of x square plus 5 into derivative of x square plus 5, that is d by dx of x square plus 5, that is equal to cos x square plus 5 into d by dx of x square plus 5 is nothing but d by dx of x square is 2x plus 0. Derivative of constant is 0. So it is 2x cos x square plus 5. Okay. So it is the derivative of this given function, sine of x square plus 5. First we will find the derivative of sine, then derivative of x square plus 5. Okay. Then what about cos of sine x? F of x is equal to cos of sine x. So here f dash of x is equal to, first we will find the derivative of cos. Okay, that is minus sine. Okay, cos x is, derivative of cos x is nothing but minus sine x, right? So derivative of cos is minus sine, the function is sine x, into derivative of this function, that is cos x. Okay, that is minus sine x into sin x into cos x, or you can write minus cos x into sin of sin x. Okay, it is the derivative of this given function, cos of sin x. First we will find the derivative of cos x, then derivative of sin. Okay. Third one, sine of ax plus b. F of x is equal to sine of ax plus b. Then what is f dash of x, or d by dx of f of x is, first we will find the derivative of sine, that is cos of ax plus b, into derivative of, that is d by dx of ax plus b, that is equal to cos ax plus b into d by dx of ax plus b. Ax is a plus b, derivative of b is 0. So derivative of ax plus b is a. That is equal to a into cos of ax plus b. Now what about this one, fourth one? See here, f of x is equal to sec tan of root x. Sec tan of root x. See here, first we will find the derivative of sec x. Okay, then tan, then root x. Okay, that is f dash of x is equal to sec, derivative of sec. Okay, you consider this whole term as x. Then what is sec x? Derivative of sec x. Derivative of sec x is nothing but sec x tan x. Right? d by dx of sec x is sec x tan x. Okay. So first we will write sec x tan x. So sec, we have considered x as this one, right? So sec tan root x. Okay. Then tan x, tan root x into d by dx of tan root x. Okay, tan root x. So here what we will do, write this as it is, sec tan root x into tan of tan root x. Okay, then into d by dx of tan root x. Here d by dx of tan is nothing but sec square, right? Sec square, d by dx of tan x is sec square x Okay, so d by dx of tan root x is sec square root x into d by dx of root x. Okay, d by dx of root x. Okay, that is why it is called the chain rule. Okay, it's going like chain, right? So first we will find the derivative of sec, then tan, then root x. Okay, so here sec tan root x into tan root x into sec square root x into derivative of root x is 1 by 2 root x. Okay, it is the derivative of this function. Fifth question, differentiate sin ax plus b divided by cos ax plus b. See, in 11th standard we studied that about derivative of that is quotient rule, right? See here, derivative of u divided by v, that is equal to derivative of u divided by v is nothing but v into denominator into derivative of numerator, okay, minus numerator into derivative of denominator divided by v square, means denominator square. Okay, that is denominator into derivative of numerator minus numerator into derivative of denominator divided by square of denominator. Okay, that is v into u dash minus u into v dash divided by v square. So here, see, it is in the form of u by v, right? So here also, here we will apply quotient rule. Okay, quotient rule and chain rule also. Okay, quotient rule, then chain rule. Okay, so let's see. Here f of x is equal to sin ax plus b divided by cos ax plus b. That is equal to, okay, f dash of x is equal to, first we will apply quotient rule, that is u by v. Okay, then that is denominator into cos of ax plus b into derivative of numerator, that is d by dx of sin ax plus b, okay, minus numerator into sin of ax plus b into derivative of, that is d by dx of denominator cos ax plus b, whole divided by square of denominator, that is cos square x plus b. Here no derivative, square of denominator, that is cos square x plus b. Now see here, now let's find the derivative, where we have to find the derivative. Cos ax plus b, okay, into here derivative of sin ax plus b. Derivative of, here we will apply chain rule, okay. Derivative of sin x of sin of x plus b, not sin x plus b, okay. Sin of x plus b, that is function of function, okay. So d by dx of sin of ax plus b. So here first we will find the derivative of a sine, that is cos ax plus b into derivative of x plus b, okay. That is sine derivative is cos ax plus b into derivative of ax plus b is nothing but a, then minus sin ax plus b into derivative of cos ax plus b. Derivative of cos is, first we will find the derivative of cos, okay. So derivative of cos is minus sin x plus b into derivative of ax plus b is a, whole divided by here cos square ax plus b. Okay, then here see we have found the derivative of this function. So just simplify cos ax plus b into cos ax plus b, that is here a into a is a constant, cos square ax plus b, okay. Cos ax plus b into cos ax plus b is cos square ax plus b, okay. here minus into minus, so it will become plus. Sin ax plus b, sin ax plus b. Okay, here not it is minus, it is into minus. Okay, not subtracting, into minus. So we can multiply this minus here. So minus into minus plus sin ax plus b into sin ax plus b, that is sin square a plus b and this constant a here. Okay, sin square ax plus b whole divided by cos square ax plus b. See here, a is common in both terms, right? So let's take a outside. So after that we will get a into sin square ax plus b plus cos square ax plus b divided by cos square ax plus b. Okay, so what is this one? Sin square ax plus b plus cos square ax plus b. Sin square x plus cos square x is 1. Okay, that is the first identity of our trigonometry function. Sin square x plus cos square x is equal to 1. So here similarly sin square ax plus b plus cos square ax plus b is 1. So our answer will be a divided by, okay, it will be 1, a into 1, okay, a into 1 divided by cos square ax plus b. That is equal to, here a divided by, so or 1 divided by cos square ax plus b. 1 by cos square is nothing but sec square, right? So sec square ax plus b into a. So it is the answer. A into sec square ax plus b. It is the derivative of this function. Next question is cos x cube into sin square x raised to 5. See, it is nothing but product of two functions. Okay, in 11th standard we learnt about a product rule, right? Product of two functions, for finding the derivative of a product of two functions. That is derivative of u into v. Okay, u and v are two functions. Then product of u into v, derivative of u into v is nothing but u into v dash plus v into u dash. Okay, that is first function into derivative of second function plus second function into derivative of first function. Okay, it is the product rule. So here we will apply product rule and chain rule too. Okay, so here see, it is the function, first function, consider it as first function, next it as second function. Okay, then first function, so let y is equal to, or you can take f of x is equal to, okay, whatever, cos x cube into sin square x raised to 5. It is the given function. Okay, so dy by dx, or we can write y dash, that is equal to first function into cos x cube into derivative of second function, okay, that is dy dx of sin square x raised to 5 plus second function into sin square x raised to 5 into derivative of first function dy dx of cos x cube. Okay, that is equal to, here cos x cube into derivative of sin square x raised to 5. Derivative of sin square x raised to 5. So here we will apply chain rule. Okay, so because first we have to find the derivative of sin square. Okay, sin square, then sin square means power. Okay, it's power. So first we will find the derivative of power, then sin, then x raised to 5. Okay, don't be confused. See, sin square x raised to 5 means we can write it as sin x raised to 5 whole square. Right? That is sin x raised to 5 whole square. We know that sin x whole square is nothing but sin square x. Okay, sin x whole square is sin square x. So first we will take the derivative of power. Okay, that means this power. Okay, so here derivative of sin square x raised to 5 is, see, what about sin square x? Consider this as x. Okay, so it will be sine square x. Derivative of sine square x is nothing but 2 into sine x. Okay, that is x raised to n. X raised to n derivative is n into x raised to n minus 1, right? So 2 into sine x, okay, that is 2 into sine raised to 2 minus 1. So 2 sine x into derivative of sine is cos x, okay. But here in place of x, here x is raised to 5. Then again we have to take the derivative of x raised to 5. See here, first we will take the derivative of power, that is 2 into sine raised to 2 minus 1, that is 1, okay, sine raised to 1, so sine x raised to 5 into derivative of sine, okay, next we will take the, here we have just taken the derivative of power, okay, then next here we have to take the derivative of sine, okay, that is cos x raised to 5, next into derivative of x raised to 5, okay, into derivative of x raised to 5, that is 5x raised to 4, okay. First taken the derivative of square, that is derivative of x square is 2x, right, like that. Here 2 into sine x, here in place of x raised to 5, okay. Then derivative of sine, okay, that is function of function, here 3 times, okay. So sine of x raised to 5, right, so that is cos of x raised to 5 into derivative of this function, that is x raised to 5. So derivative of x raised to 5 is 5x raised to 4, that's all. Next is then plus, here no need to take the derivative, okay, sine square x raised to 5 into derivative of cos x cube. So derivative of cos, first cos, derivative of cos is minus sine, so minus sine x cube into derivative of x cube, that is 3x square, okay, that is equal to here cos x cube into 2 sine x raised to 5 into, okay, so we can write it as 5 x raised to 4 into 5 into 2, it will be 10, okay. So 10 x raised to 4 into cos x cube into sine x raised to 5 into cos x raised to 5, okay, plus it will be minus, okay, one minus is here, so minus, then 3x square square x raised to 5 into sine x cube, okay, into sine x cube, okay, it is the derivative of this given function. Into root of cot x square, let y is equal to 2 into root cot x square. So dy by dx is equal to, here first of all 2 into then derivative of root cot x square, that is first we will take the derivative of root, okay, that is what is the derivative of root x, 1 by 2 root x. So consider this all as x, okay. So here into 1 divided by 2 root x, right, so 2 root cot x square into next derivative of cot. Derivative of cot is minus cosec square x, okay, cot x is x, minus cosec square x, so here x square. Then next derivative of x square is 2x, derivative of x square is 2x. So here 2 cancelled, so minus 2x into cosec square x square divided by root cot x square, okay. So let's simplify this one. Here minus 2x into cosec square x square can be written as, see what is cosec square x, 1 divided by sine square x, right. Cosec square x is 1 by sine square x, right. So cosec square x square is 1 divided by sin square x square. Okay. So here 1 by sin square x square. Okay. Then into square root of cot x square. See, how can we write square root of? It is in denominator, right? So let's write in denominator first. Okay. 1 by root cot x square means we know that cot x is cos x divided by sin x. Okay. So cot x square is cos x square by sin x square. So root of this is root cos x square divided by root sin x square. So here we can write root cos x square divided by root sin x square. Take this. Okay, it will be here in denominator of denominator will be numerator, right? So that is equal to minus 2x into, here it will be denominator, sorry, numerator. So root sin x square divided by sin square x square into root of cos x square. Okay. So here minus 2x into, see, sin square x square can be written as sin x square into sin x square, right? Sin into sin square. Okay. And this sin x square can be written as root sin x square into root sin x square, right? Into this sin x square. So that we can cancel this root sin x square, right? So here remaining one sin root sin x square will be cancelled. So remaining root sin x square into sin square x, right? Sorry, sin x square. Okay, so this one cancelled. So divided by here root sin x square into sin x square. Okay, into root cos x square. Cos x square. So this can be written as minus 2x divided by sin x square. So this can, we can take these two together. Okay, square root of, inside of a square root, because we know that square root of x into square root of y is nothing but square root of x into y, right? So here square root of sin x square into cos x square. Okay, that is equal to, see what is sin x cos x? We know that 2 sin x cos x is 2 sin x cos x is sin 2x, right? So only sin x cos x is sin 2x divided by 2. Okay, sin x cos x is sin 2x divided by 2. So this can be written as, it is equal to minus 2x divided by sin x square into square root of sin x square into cos square x is square root of this one sin 2x square. Okay, sin 2x square divided by 2. Okay, sin 2x square divided by 2, because sin x cos x is sin 2x divided by 2. So sin x square cos x square is sin 2x square divided by 2. Then, okay, that's enough. That's all. Next is cos of root x. Let y is equal to cos of root x. So dy by dx is equal to derivative of cos is minus sin root x. Okay, into derivative of root x is 1 by 2 root x. Okay, that is minus sin root x divided by 2 root x is the answer. Look at next question. Prove that the function f given by f of x is equal to modulus x minus 1, x belongs to R, is not differentiable at x is equal to 1. Okay, here we have to prove this function is not differentiable at x is equal to 1. To prove that, we have to prove that left hand derivative is not equal to right hand derivative at x is equal to 1. Okay, so first of all, let's write the function. So here we know that modulus x is equal to minus x when x less than 0. Modulus x is equal to plus x when x greater than 0, right? So here, what about modulus x minus 1? The same way we can write modulus x minus 1 is equal to, okay, minus of x minus 1 when x minus 1 less than or equal to 0, right? And plus x minus 1 when x minus 1 greater than 0, okay? So it is, okay. So here, see, it can be written as minus of x minus 1 means 1 minus x, right? Multiply this minus to each terms in the bracket, that is minus x plus 1, so 1 minus x. So 1 minus x, when take this minus 1 right side, so it will be x less than 1, right? Means x less than 1, okay? So here, when x minus 1, here x greater than 1, okay? So modulus x minus 1 is equal to 1 minus x when x less than 1, okay? And modulus x minus 1 is equal to x minus 1 when x greater than 1, greater than or equal to 1, okay? So here, now let's find the left hand derivative and right hand derivative at x is equal to 1, okay? So first of all, left hand derivative, that is f dash of 1. Okay, we have to find, here we have to prove this function is not differentiable at x is equal to 1, right? So f dash of 1, that is equal to limit h tends to 0, that is our definition of the left derivative, okay? So limit h tends to 0, f of c minus h, right? Here c is equal to 1, so 1 minus h minus f of 1, okay? Divided by minus h. So that is equal to limit h tends to 0, f of x. See here, it is left hand derivative. So it is h tends to, not h tends to 0, h tends to, yes, h tends to 0, h tends to 0. But here the point is 1, okay? And here the left hand derivative, so it is less than 1, okay? The point is less than 1, means left hand derivative at x is equal to 1, right? So that is left of 1, okay? So left of 1 means that is x less than 1, the function is 1 minus x, okay? So 1 minus h, so f of 1 minus h, see here f of x is equal to 1 minus x, so f of 1 minus h is, in place of x you have to put 1 minus h, so 1 minus h, okay, minus f of 1, here f of x is equal to 1 minus x, okay, it is f of x, modulus of x minus 1, so f of x is equal to 1 minus x, so f of 1 is equal to 1 minus 1, that is 0, divided by minus h, that is equal to limit h tends to 0, here 1 minus 1, multiply this minus to each terms, so minus plus h, okay, so plus h divided by minus h, that is equal to, here 1 minus 1 cancelled, so h by h, limit h tends to 0, h divided by minus h, that is equal to minus 1. Okay, h by minus h is minus 1. So limit of minus 1 is minus 1 itself. So next we will find the right hand derivative at x is equal to 1. Right hand derivative at x is equal to 1 is limit, the definition, limit h tends to 0, f of 1 plus h minus f of 1 divided by h, okay, plus h. That is equal to, see here, f of x is equal to x minus 1 when x greater than or equal to 1. Okay, here right hand derivative at x is equal to 1 means the values at x greater than 1. Okay, so here the function is x minus 1. So f of x is equal to x minus 1. Okay, f of x is equal to x minus 1. So what is f of 1 plus h? In place of x we will write 1 plus h. Okay, 1 plus h minus 1. That is 1 minus 1 cancelled h. So here f of 1 plus h is h minus f of 1. F of x is equal to x minus 1. So f of 1 is equal to, substitute x is equal to 1. So 1 minus 1 is 0. Divided by, we should write limit, okay, limit h tends to 0, h minus 0 divided by h. So limit h tends to 0, h by h, that is equal to 1. Okay, that is limit h tends to 0, 1, that is 1 itself. So here we have got left hand derivative is not equal to right hand derivative at x is equal to 1. Therefore, left hand derivative is not equal to right hand derivative at x is equal to 1. Therefore, hence f of x is equal to modulus x minus 1 is not differentiable at x is equal to 1. Prove that the greatest integer function defined by f of x is equal to greatest integer of x 0 less than x less than 3 is not differentiable at x is equal to 1 and at x is equal to 2. So here also let's find the left hand derivative and right hand derivative at x is equal to 1 and at x is equal to 2. Okay, we know that what is the greatest integer function? It is the greatest value less than or equal to x, right? Okay, so here suppose let us take at x is equal to 1. Our function is f of x is equal to greatest integer of x. So what is f of 1? That is greatest integer of 1 is nothing but 1 itself. Okay, greatest integer of 1.5 is 1. That is the greatest value less than or equal to 1. Okay, less than 1.5, greater than, that is it is the greatest value, largest value, less than 1.5 is nothing but 1. Okay, so here, so f of 1 is equal to greatest integer of x, that is greatest integer of 1 is equal to 1. So now let's find the left hand derivative. Okay, left hand derivative f dash of at x is equal to 1, right? So f dash of 1 is equal to limit h tends to 0 f of 1 minus h, okay, c minus h, here c is equal to 1 minus f of 1 divided by minus h, that is equal to limit h tends to 0. Here what is f of 1 minus h? See, 1 minus h means it is the value less than 1. Okay, 1 minus h means less than 1. H is a small value. So 1 minus h will be less than 1. So when it is less than 1 means 0.99 or 0.89 something. Okay, so 0.9. See, what is the greatest integer of 0.9? That is nothing but 0. So what is 0.99? 0, right? So here greatest integer of 0. Something is 0. Okay, so here f of 1 minus h means, 1 minus h means that is a small value, that is less than a value less than 1. Okay, less than 1 means 0 point something. So its greatest integer is nothing but 0. So here it is 0. Okay, minus f of 1 is 1 divided by h minus h, that is equal to limit h tends to 0, minus minus cancelled. Okay, 0 minus 1 is minus 1, minus 1 by minus h, that is 1 by h. See, here we have got limit h tends to 0, 1 by h. See, 1 by h, when you substitute h is equal to 0, you will get 1 by 0. It is not defined, right? 1 by 0, it is not defined. Therefore, here we can say it does not exist. Okay, this limit, this left hand derivative is not existing. Okay, it does not exist. So here does not exist. Okay, so left hand derivative does not exist. Therefore, here we say the function f of x is equal to greatest integer of x is not differentiable at x is equal to 1. Now let's check about x is equal to 2. Okay, at x is equal to 2. Okay, here we can write function f of x is equal to greatest integer of x is not differentiable at x is equal to 1. Okay. Next, what about at x is equal to 2? So here also let's find the left hand derivative, or you can check right hand derivative. Okay, left hand derivative, let's find L f dash of 2. Okay, at x is equal to 2. That is equal to limit h tends to 0. Here f of 2 minus h minus f of 2 divided by minus h. That is equal to limit h tends to 0. Here what is f of 2 minus h? 2 minus h means it is less than 2, right? The value is less than 2. When less than 2 means 1 point something, right? So greatest integer of 1 point something is nothing but 1. Okay. So it is 1 minus f of 2. F of x is greatest integer of x. So f of 2 is greatest integer of 2. That is f of 2 is equal to greatest integer of 2, that is 2 itself. Okay. So f of 2 is 2 divided by minus h. So here 1 minus 2 is minus 1. So limit h tends to 0 minus 1 divided by minus h, that is limit h tends to 0 1 by h. See here also we have got same thing, limit h tends to 0 1 by h. When we substitute h is equal to 0, it will be 1 by 0 and it is not defined. Okay, so here also the limit left hand derivative, okay, left hand derivative does not exist at x is equal to 2. So here also we say the function greatest integer of x is not differentiable at x is equal to 2. So here we can write, therefore f of x is not differentiable at x is equal to 2. Okay. The derivative does not exist.